Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Hello, hey there, lesson 8, where are you? Here we are. How do dilations map lines, rays, and circles? Classwork opening exercise. Is a dilated ray still a ray? If the ray is transformed under a dilation, explain how. Okay. Well, it's a tough question. Got to put some thought into this one. Here's a ray. Definition of a ray is we have a starting point, and then we go off in a direction, and the arrow means it goes on forever, like the sun's rays. So if you dilate something that goes to infinity, then r times infinity is still infinity, and even if r is between 0 and 1 or greater than 1. So it would still be a ray under a dilation. Now, if we were talking vectors, vectors take a point a certain direction and a certain distance. So if we dilated a vector, then it would have a different endpoint, shorter. So I guess that's enough said about that, I guess. Part B, dilate ray PQ by a scale factor of 2 from center O. Okay, so here they're going into more detail and they're calling it ray PQ, but the 2 points that they're using to name it, P is our starting point or at the initial location, and Q is somewhere on the ray. So what we're going to be doing is just simply moving Q somewhere else. So it says dilate the ray PQ by a scale factor of 2 from center O. So the first thing I would do is get my ruler, go to the top of the screen where it is not. Okay, and put my ruler right on O. Rotate and draw a ray. I'm just trying to be real accurate here. And draw a segment. Starting at O and going through Q. So there is ray OQ. And then do the same with OP. So if I do this, there's a couple of different ways I can do this. And I'm going to do it both ways. So it says to dilate PQ by a scale factor of 2 from center O. I guess there is only the one way to do this. Okay, so once we do that, let me put my ruler back. Let me switch it to metric. From O, let me get it right on 0. Come on. All right, so let me reset my pen. From O, trying to get that right at 0. So I need to accurately measure this. Right there. OP is 4.9. So I write this over here. OP equals 4.9. And it says by a scale factor of 2. So OP prime is going to be twice 4.9 or 9.8. So I come out to 9.8 and put a dot right there. Rotate this up to OQ. And let me label this after I got that out of the way. And this will be P prime. And then I measure from here, 0 to here, 3 point, it's hard to see, and I'm not quite at 0, it's up a little. Okay, 3 point, can't see that, 3.5 is coming down, okay, I see now. So here's 3.5, 3.6, 3.7. OQ equals 3.7. And these are all centimeters, but unit of measure is not quite so important at this moment. So OQ prime equals 3.7 times 2, which is 7.4. And that is right here. So I move my ruler out of the way, and that is Q prime. And then I bring my ruler over to P, rotate it to Q, and this would be my ray, P prime, Q prime, dilated by 2 from O. The other way I was thinking of doing this was measuring PQ, and it's 4.7, 4.8, somewhere around there, and doubling it and just moving it up to here, bringing Q up here, but that wouldn't be dilated from center O. And then I says, is the figure P prime, Q prime a ray? And the answer is yes. P prime, Q prime is a ray. So can we dilate a ray? And the answer is yes. If you have a starting point and a point on the ray, then the point that's on the ray does get moved further from the initial location. All right, page 2 brings us to a couple more questions about that ray that we just did. And it starts off with number 2 saying, how far, how, if at all, has the ray PQ been transformed? So how has it been transformed, if it's been transformed at all? And the answer is the segment P prime, Q prime in ray P prime, Q prime. Okay, so let's go talk about that. The segment is here to here. The segment in the ray is what they're saying. The segment P prime, Q prime in the ray P prime, Q prime is twice the length of the segment PQ in ray PQ. The segment has increased in length according to the scale factor of dilation. Okay, so all they're saying is the distance from P to Q here has doubled. Now Q prime is twice as far from P prime on this ray, which does go on forever, but the points that name it are further apart. Okay, so part 2. Will a ray always be mapped to a ray? And explain how you know. And the answer is, and it says here, students will most likely say that a ray always maps to a ray. They may defend their answer by citing the definition of a dilation and its effect on the center and a given point. Alrighty. All right, so example 1. Will a dilation about center O and a scale factor R equals 1 map PQ to P prime, Q prime, and explain? Okay, so when we have a scale factor of 1, you're creating something, a copy, if you will, but it's sitting right in the same location as the pre-image is. So the pre-image and the image are identical and they're in the same location on the plane. So here's the answer written out here. A scale factor of R equals 1 means that the ray and its image are equal. That is, the dilation does not enlarge or shrink the image of the figure, but remains unchanged. Therefore, when the scale factor of a dilation is R equals 1, then the dilation maps the ray to itself. Okay. Example 2, the line that contains ray PQ does not contain point O. Okay, so what are they talking about here? So let me draw a picture. Remember, a line goes to infinity in both directions. So say we have this line right here, and it contains the ray PQ. So if I put a dot right here and call it P, and put a dot here and call it Q, ray PQ would be a ray that starts right here and goes in this direction, and it would not include, so let me show you what I mean by this. Let me just do this. I'm just covering it up so you can see what's going on here. So if I cover this, come on, like so. Okay, there's ray PQ, but if I move that box, that's line PQ. So ray PQ is on line PQ. Does that make sense now? And it does not contain a point O. Okay, O is over here. Does a dilation about center O and a scale factor R not equal to 1 map every point PQ onto point P prime Q prime? That is the question. Okay, so here's a diagram to explain that better. So the line that contains PQ would be right here, continuing it forever. It does not contain the point O. A dilation about center O and a scale factor not equal to 1, in this case it's greater than 1, will it map every point on PQ onto a point of P prime Q prime? So in other words, did P get mapped to P prime? Did Q get mapped to Q prime on another ray that is on a different line that is parallel? And the answer is yes, it will. Okay, page 3, example 3. A line that contains ray PQ contains point O. Does a dilation about the center O and a scale factor R map PQ to P prime Q prime? Examine the case where the endpoint P of PQ coincides with the center O of the dilation. Okay, so in this diagram, we're putting O in all the possible locations. And let me explain. So the line that contains PQ. So there is a line up here. P is here, Q is here, and point O is here. It says, does a dilation about center O and a scale factor of R map PQ to P prime Q prime? So O can be in between P and Q. O can be at the same location as Q, or O can be out beyond P and Q here. See the 3 different possibilities? O is between P and Q, O is Q, or O could be out further from P and Q. So P is here, Q is here, and then the center of dilation is to the right of them. So where the endpoints, and it says to examine the case where the endpoint P of line or ray PQ coincides with the center. So when they say coincides, mean dilation, the endpoint P of PQ coincides with the center O of the dilation. Okay. So these are the 3 possible outcomes. Okay, so I covered the first 2 up for this one because what they're talking about is the first situation. So it says examine the case where the endpoint P of PQ coincides with the center O. So what they're saying is it would be this line here, but P would be right here with O. So this is also P. So P is not down here anymore, P is here. What would happen there? And it would map OR onto itself, because if I dilate OR and O is equal to P, no matter what R is, OR would just be OR. Okay. Examine the case where the endpoint P of PQ is between O and Q. So now we're going to move P between O and Q. So let me do this. So if it's between O and Q, that would put P over here and O is to the left. What would happen there? Okay, I want to say more about A. And I found better diagrams to explain this. So it says to examine the case where the endpoint P coincides with center O. So there's O and P equal. And what they're saying is you have the ray OQ. So if R, scale factor R is greater than 1, then you pick a point that's between O and Q, and you scale it out, then its image would end up on the other side of Q, because R greater than 1 is going to go further from O. And if R was less than 1 and our image being X would get moved this way to our image X prime would get moved from image pre-image X, okay? And in this case, our pre-image X is between O and Q, and it would end up getting moved away from our starting point O, which equals P. Okay, so now B says, examine the case where the endpoints P of PQ ray is between O and Q. So now we're going to move P over here somewhere between O and Q. Okay, so here is a diagram for B. So endpoint P of ray PQ, endpoint P of ray PQ. So ray PQ starts here and goes this direction, because P is here and Q is here. So P is between O and Q, which is our point of dilation. What will happen? Well, if R is greater than 1, then P will move to P prime this direction. And if you have some arbitrary point anywhere on that ray, PQ, it is also going to move to the right. If R was less than 1, then the dilation P would move closer to O, further from X. So P, the starting point P would move this way. Q would also move that way, but not at the same rate. Okay, and then part C, examine the remaining case where center O of the dilation and point Q are the same side of P on the line containing O, P, and Q. Okay, so I didn't want to erase that. This is where we would look at these three situations. All right, so we have everything to the right of P. So here's our starting point P. O's here, Q's here, R's here. O and Q are sharing a location, and R's over here. And PQ is shorter than PO here. PQ is longer than PO here. PQ equals PQ here. These are the three possible outcomes for having our center of dilation and our other point to the right of our starting point. Okay, so I noticed in this that we have example 3, and then we have example 5. So I'm not sure if your student module hard copy that you have, if you have one, has an example 4. Unfortunately, the electronic version skipped it. So I'm not going to do it, of course, because I don't have it. So here's example 5. Does a dilation about center O and a scale factor of R map a circle of radius R onto another circle? Examine the case where the center of dilation coincides with the center of the circle. Examine a case where the center of dilation is not the center of the circle. We call this the general case. Okay, so here are the 2 diagrams that I brought in to explain this. So does a dilation about center O and a scale factor R map a circle of radius R? So here is circle O, radius R, point P on the ray OP. Examine the case where the center of dilation. So this is circle, they're calling it circle C, even though it's centered at O, usually we name our circles. So anyway, this point would be called C and O is on C. How's that? So that's circle C, centered at the point right here is where C would be as well. is O, and that is our point of dilation. R is our radius. P is a point on our original circle. Now, if I extend that ray out, OP, a certain distance, and I scale the circle out where R is greater than 1, since the circle is larger, C prime is out here, our pre-image is the inside circle from here, and our outside circle is our image. So we went out a scale factor and moved P to P prime here, and therefore every single point on that circle should be the same distance out, because the radius would be R times R. R lowercase being our scale factor, capital R being our radius. So if we multiply the radius by the scale factor, our new radius would be the C prime circle. Now it says to examine the case where the center of dilation is not the center of the circle. We call this the general case. Okay, so here's our diagram. We have a circle C centered at the O, which is our point of dilation, radius R, and there's a point P on circle C, and then there's a point out here called D. So the center of dilation is not the center of the circle. We call this a general case. So I don't know why they have an O here and calling this D. It looks like this point out here would be our center of dilation. So here's our original diagram. Okay, so just to save time, I brought this in. So if you will, this is our new circle. So D is our center of dilation. And how do I know this? Well, if I drew a ray through P, it's going through P prime. If I continue this with any point, there's S going through S prime. So D is our center of dilation, but they have an O here, and I have a problem with that. So let me fix this. So if you're copying this diagram, let's call this O. What's going on? Let's call this O, not D. Let's get rid of this O here and call that C, because we name a circle by the center. So this is not O, it is C, and we're changing D to O. Okay, that makes more sense. I have no idea why they're calling the center O when we're not dilating from the center. Okay, so every single point, including the center, so this would be C prime here, gets dilated out. So the difference between the two is it's a circle with the same center, and it's almost looking like a target if you repeat it. And in this case, the entire circle, including the center, gets moved and enlarged. So those are the two possible outcomes where we dilate a circle. All right, page 4 brings us to the end of lesson 8. Review the lesson summary on the dilation theorems for 3 different items, objects, and go to your problem set.